Hello everyone. How are you guys doing today? I was okay up until half an hour ago, but now I'm feeling so bad. So I was really about to cancel the class, but then I was like, all of you are here, I know. And so let's just have the class. But maybe we're going to leave early today. If I feel worse, then I'm going to leave soon. I just threw up. I don't know why. Like, I was fine in my morning class, and then suddenly I felt so bad. My voice is now bad because I threw up hard. So it's probably bleeding inside. Yeah. So I'm going to talk slow today, okay? Slower. If you can't hear me or don't understand me, please ask me, okay? We are done with chapter 10 last week, and today we're going to start chapter 11. And next week, Monday, there is no class. And Tuesday, we're not going to meet because Tuesday will follow Monday's schedule. So next week, Tuesday, you're going to go to your Monday classes. And Monday, there will be no class. Okay? So chapter 11 talks about quadratic, all about quadratic equation, quadratic graphs, transformation, solving quadratic, transforming quadratic graphs, solving quadratic equation. Some function didn't look like quadratic, but we can solve them using quadratic methods, or how do you solve quadratic equations, all these things. Also inequality. So chapter 11 is a big section. Our exam 2 will be end of this month, or at least on the 3rd week or the 4th week. 3rd week is next week. No, next week is 2nd week. So either on the 3rd week or on the 4th week. Okay. October, this month. I will make a review sheet when I can. I have a research paper due next week, Thursday, so I have to work on it first. And then I'll make the review sheet. And our exam 2 will be based on chapter 10, whatever we didn't do for exam 1. So the materials after exam 1, and then probably half of chapter 11. Any question? Any comments? Concern? Nothing? Okay. So before we solve anything algebraically, let's use some common sense to figure out the answer. If they ask you x squared equals to 4, solve for x. So we know we can easily solve for x by taking the square root on both sides, right? We can easily take the square root on both sides. But without doing this algebraically, if I ask you what number when you square, it turns into 4, what numbers you're going to tell me? Definitely it's 2. 3, there is also another number, -2. So if you try to take the square root, the only number comes in your mind is the +2, and you forget about the -2. But there are two numbers when you square, they turn into 4, positive and -2. That's why when you take the square root on both sides, you're supposed to get 2 outcomes. One is positive, one is negative for your variable. Now, what number when you square turns into 9? Definitely one of them is 3, but 3 is not the only one, right? We also have a -3. So if you try to solve this algebraically, we know you have to take the square root on both sides. So we get x on the left, but on the right side, there are 2 choices. One is positive, one is negative. And now you know why 2 choices. Because of the logic. What number when you square turns into 9 or turns into 4. How about 49? What number when is square turns into 7? Sorry. What number when is square turns into 49? So see, sometimes our brain works faster than our heart. I was thinking about asking you 49, but my brain gave you the answer, 7. So we have 7, but 7 is not the only answer. We also have -7. And how about 100? What number square gives you 100? 10 and -10. So the bottom line, anytime you take the square root of a variable, if you have a variable and you need to take the square root of the variable, there are two numbers, there are two choices always you're going to have, except in one case. During one case, when you take the square, you take the square root of a variable, square root of a square, but the answer doesn't have plus minus sign. Good job, you're smart. Yeah, there's only one time. When you have a square equals to 0, and you take the square root, only at that time we don't have plus minus sign. We have only 1 0. Besides this scenario, any other time, if you take the square root of any variable, it doesn't matter what variable you have, square root of any variable, there always has to be two choices, positive and negative. Okay? Now, using this knowledge, we are going to solve quadratic equation of different types. For example, the first one, we have x squared minus 14 equals 0. Our goal is to get the epsilon or solve for x. So what do we do? First method, so not method, first step, plus 14, just like before, we need to add 14 to both sides. So we get x squared equals 14. Now, logically, we cannot solve this, right? What number when you square turns into 14? It doesn't work logically here. So we have to use algebra. We take the square root on both sides. So we get x on the left. And how about the right side? What do you get? Do you know what is square root of 14? No. So we keep our square root of 14. But how many choices we have? 2. One is plus, one is minus. So we have two numbers. One is square turned into 14. One is positive 14 square. Another square root gives you 14. Or negative square root of 14 square will give you 14. This is what it means. There are two choices. When you take the square root, when you take the square of turns into 14. So you cannot forget your plus minus sign. You have to always, except for one case, you always have to write plus minus when you take the square roots. It's true only for square root, only for even root, okay? It's not true for odd root. For odd root, it doesn't happen. For even root, it does happen. Now, how about the next one? Our goal is to solve for x. So what is our first step? 24 is already subtracted. So we add, right? Did you say add? Yeah. I thought you said subtract, sorry. See, my hearing is not good today because my throat is hurting so bad. So my brain is keep thinking about my throat. It's burning, it's burning. So we add 24 to both sides. We get x squared equals 24. And now, what do we do? Square root. So this cancel out, we get x. And what do on the other side? Plus minus square root of 24. But guess what? This answer is not acceptable. It's not wrong, but it's not acceptable. Why not? Simplify. Anytime you can simplify anything, you have to simplify. So how can you simplify? 16? 16? No, 16, you cannot divide 24 by 16. 8 and 4. No. Come on, Daniel, what are you giving me today? 6 and 4. I was like, 8 is a square number. Like, it's 6 and 4. We have to reduce. If your radical is reducible, you must reduce. So square root of 4 gives you 2. So you have x equals plus minus 2 square root of 6. And this plus minus means there are two answers. One is positive 2 square root of 6, and one is negative 2 square root of 6. We are lazy, so we put them together as plus minus symbol. Any questions so far? Okay, now next type. Let's try doing it logically first. What number, when you subtract 1 and square, turns into 1? What could be one number? At least one number you can think of. 2. And now this one is not working, so let me restart. Give me 1 second, let me restart this again. I don't know why what does it. It always gives me this issue. I can try it. Which one am I doing? This one. So definitely one of them is 2. Right here. Let's take a page. X minus 1 square equals 1, and the other one is x minus 1 square equals negative 1. So this one, we know definitely one of them is 2. 2 minus 1 is 1, 1 square is 1. But is 2 the only number? What are the number we have? 2? 0. Another one is 0. 0 minus 1 is negative 1. And negative 1 square is positive 1. You see, we had 2 choices. But we don't have to do this mentally. We can do it algebraically. But mentally, I'm showing you that it doesn't matter what you do, it's supposed to have 2 results. So algebraically, when you try to apply the square root on both sides, we know the left side becomes x minus 1. How about the right side? What do you get on the right side? Only 1? Remember, it doesn't matter what you take the square root of. Any variable when you take the square root of, it has to give you plus minus symbol on the other side. It must. Why? Because we had 2 choices for our answer. So it's plus minus 1. What is square root of 1? 1. It is reducible. So what does that mean? It means you have x minus 1 equals negative 1 or x minus 1 equals positive 1. This is what it means, plus minus 1. There are 2 choices. Now, when you try to solve for x, what do we need? Add 1 on both sides, right? So first one gives us x equals 0, and second one gives us x equals 2. Do you see? We're supposed to have 2 answers because we already know that from before, and now we do have 2 answers. So if you forget your plus minus symbol, you're going to have only one number, which is 2. And your math is not wrong, but it's incomplete, so you're not going to get points. Okay? Any questions so far? The last one. Logically, we cannot do that because our right side is -1. Can you think of any number when you square turns into -1? Is it possible? Definitely, we're not going to have any real number this time. So we are imaginary numbers. So we take the square root on both sides. The square root and square cancel out. We get x minus 1. And what is square root of -1? I. So should I write only I? Plus minus. That plus minus comes from the square root on the left side, okay? And whatever we have on the other side turns into I. But the plus minus, anytime you have plus minus, that because you take the square root of the variable. Square root of the variable gives you two choices. But square root of a number is always 1 positive. But square root of a variable is 2 numbers. That gives us 2 numbers. So we add 1, sorry. Let me show you this one. We add 1 to both sides. So we get x equals positive I plus 1 and x equals negative I plus 1. But doesn't it look weird? Do you remember what the format for any complex number? A plus bi. So even though they're not wrong, but they're not acceptable either. We have to write the real number first. So x equals 1 plus I and 1 minus I. So when you solve radical equation, sometimes we get whole number. Sometimes we get radical that is not reducible, like the 14. Sometimes we get radical that is reducible, like 24. Sometimes we get to real numbers. Sometimes we get to imaginary numbers. So there are many choices we have when we solve radical equations. And we are going to use this knowledge to solve other types of equations. But that's the main idea. Anytime we take the square root, can I write now? No. Anytime we take the square root of a variable, the main thing is variable. So let me write this. Square root of a variable. Only variable, okay? Square root of a variable gives you two choices because you don't know your number. A variable could be the positive number or could be the negative number, like 2. It could be 2 square, it could be -2 square. You get 4. However, square root of a number, I should write number. Square root of a number has only one choice, positive number. Square root of a number has to be positive and square root of a variable has to be plus minus. For example, if we have square root of 16 alone without any variable next to that, the answer is only 4, the positive 4. However, if they give you x squared is 16, and now you're finding x is square root of 16, see you have x on the other side? So you have two choices, plus or minus 4. Okay? Square root of a variable gives you 2 results, but if you don't have any variable, only number, square root of a number gives you only 1 result, the positive one. Any question before we move on to the next topic? Any comments, concerns? Nothing yet? So now our goal is to solve radical equation. Point is, sorry, not radical equation, what I'm saying? Solving quadratic equation. Quadratic means our highest degree is 2. When you solve quadratic equation, there are many methods. But before we go, let me clarify something for you. There is one called quadratic function, and there is one called quadratic equation. For a function, you have to have a y on one side or f of x. Okay? When you have y or f of x on one side, it's a function. But when you have a number on one side, it could be 0, it could be number, it could be variable. You have anything besides y or f of x, then it's an equation. Okay? We can solve an equation, but we cannot solve a function. Function, we can graph, we can simplify, we can factor. But equation, we can solve, means we can get the x alone. How many ways we can solve? There are many methods. One of them is by factoring, if it's factorable. Or you can use complete the square. Or you can use quadratic formula, but they have to memorize the quadratic formula correctly. And then the last method is graphing. If you know how to graph, then you can graph it. But the downside of the graphing is that you have to graph accurately. Otherwise, you cannot see your x-intercept. Especially if you have non-whole number, non-integer solution, like square root of 2 as your answer. Definitely cannot find it on the graphing, because we cannot graph square root of 2 on the graph. So graphing is the worst method. And then the best is a factoring if it's factorable. Factoring has a downside. Not every quadratic is factorable. So if it's factorable, your life is easy. Always factor first, and then that each factor equals 0, solve for us. And then between quadratic formula and complete the square, they both are even. None of them has any benefit. For quadratic formula, you have to memorize the formula correctly. That's the downside. And most people, they don't remember the formula correctly during the exam. So let's see, what do we have? Factoring, we did many factoring already. Remember we did graphing, right? Well, I'm teaching pre-calculus and algebra at the same time. And the first part of the pre-algebra is algebra. Not pre-algebra, what else? Come on, first part of pre-calculus is kind of algebra. So I'm forgetting what I taught in pre-calculus and what I'm teaching here. So I don't even remember. Did we go over for factoring in this class? Not really, right?
Are you going to teach pre-calc next semester?
Probably not. They gave me to algebra. But I'm recording my lecture. So if you think my explanation is easier, then you can just watch the recording. So factoring, we don't have factoring here for some reason, because factoring is done in chapter 6. We didn't do chapter 6 in this class, right? No. So let me go over factoring real quick. Let's say we have x squared plus 3x minus 2 plus 2 equals 0. And it says solve for x. Solve for x. Here we can use factoring because this is factorable. When you factor, this is direct factorable. Direct factoring means you're looking for two numbers multiplied to 2, combined to 3. So when you add, you get 3, and when you multiply, you get 2. What two numbers multiply to 2 but add to 3? 3 and 1. So you write two sets of parentheses, and you split it x squared, x and x. And you split it 2, 3 and 1. Now, whatever sign we have in the middle, that sign always has to be in front of the bigger factor. Between 2 and 1, 2 is bigger. So 2 has to have the plus sign from here. Now, if 2 is plus and you want to get 3, are you going to add the 1 or subtract the 1? Add the 1. So these are the two factors you have. And then we have equals 0 on one side. Now, when you have product of factors equal 0, one of them definitely has to be 0. But we don't know which one, so we set both of them to be 0. So it means either the first factor is 0 or the second factor is 0. One of them has to be 0. To solve, we subtract 2 and subtract 1, so we get two answers. X equals -2 and x equals -1. So we solved a quadratic equation using direct factoring. This is called direct factoring. But then factoring has many choices, many other options. Not options, like many other scenarios. This is called direct factoring because we didn't do any special anything. We just splitted our x squared and we split our constant. That's it. So we did it directly. However, not always our life will be this direct. For example, if we have 2x squared let's say this is minus 2x squared minus 5x minus 3 equals 0. Now we cannot factor directly because our x squared has a coefficient 2. So in this case, there is a method called AC. AC method. So there are many ways people can do AC method. Do you remember your AC method from before? Did you learn it in other classes? Not really? Okay. So you can do many ways the AC method. One is, especially two ways. One is correct way and one is wrong way. Okay. The correct way of doing AC method is a little bit longer. What you do is you multiply A and C. That's why it's called AC method, because you multiply A and C. So if you multiply A and C, what do you get? -6. Because our 3 is negative, right? And then you split to 6. Can you think of two numbers multiplied to -6 combined to -5? -5 times 1 is not -6. Multiply to -6. You're close. Multiply to -6. -3 times 2 is -6, but -3 plus 2 is -1. -6 and +1. So see, you're almost correct. It's on the 5, it's 6. So -6 and +1. You find two factors. Once you find these two factors, you're going to rewrite this middle term. Not 5x anymore. It should be -6x and +1x, right? -6x plus 1x give you -5x. So we need to rewrite that. The 2x squared doesn't have any problem and -3 doesn't have any problem. So you just bring them down. So what we did here is we rewrite 3 terms into 4 terms. You may wonder why we're doing 4 terms. Do you remember which method we used to factor 4 terms? Start with G. There is a word, huh? Grouping. Anytime you have even numbers, 4, 6, 8, we use grouping method to factor. So you group them into two groups. First two terms into one group, second two terms into another group. So you group them and we factor each group separately. In the first group, what do you see as common factor? 2x. So you factor out 2x. Then what is left in the first group? X minus 3. Good. Then in the second group, what do you see in the second group? Nothing, right? When you have nothing, what do you have? A 1. You have nothing to factor out, so you can factor out 1. So you keep the sign, whatever sign you have in the second group, you must keep the sign. And this time we factor out 1, means basically we have nothing to factor out. And we still have our two groups. We just factored each group separately. Now then we compare the two groups. When you look at the two groups, do you see anything in common? X minus 3. So from both groups, we can factor out x minus 3. So then what is left in the first group? 2x. And what is left in the second group? Plus 1. So we are done with factoring. We use AC methods with factors. The next step is very similar to the step we did in the last example. When you multiply two things, one of them has to be 0 if you want the product to be 0. But we don't know which one is 0. So we say, well, probably the first one is 0, or 2x plus 1 is 0. One of them definitely is 0. And if you do shortcut, we get x equals 3 here. And do you know what do you get from the negative 1/2? When you solve, we actually get x-intercepts. So all these numbers get x-intercepts. So for example, here we have two x-intercepts. One is negative 1/2 and one is 3. Here we have two x-intercepts. One is negative 1, one is negative 2. So solving for x gives us x-intercept. Now this is the correct way of doing AC method. But I love another AC method, which is incorrect. Wrong AC method. In wrong AC method, what you do is this. 2x squared minus 5x minus 3 equals 0. We shouldn't say wrong, we should say weird. Weird AC method. It's not normal, that's why it's weird. So how it's not normal? You try to factor directly. You try doing that. So you split your 3. Yeah, that's the problem. You have negative 3. So how do you know which one is positive, which one is negative? Yeah. So you do AC, A and C. And you do something weird here. So weird. This is your weird stuff. You don't write A anymore. You write x squared minus 5x. And you don't write C anymore. Instead, you write AC, which is negative 6. Okay. So A disappeared and C turned into AC. So this is step 1, the weird things. There is no A, there is no C, it turns into AC. And then we can factor this directly, right? Two numbers multiplied to -6 combined to -5. What are they? Multiply to -6 combined to -5. -6, +1. So we factor directly. But then if you look, x and x give you x squared, but we are given 2x squared. 6 and 1 will give us 6, but we are given -3. So definitely we did it wrong, right? So it's time to fix it. So how do we fix it? We do another weird thing here. See the A you see? Put A on both of them. So second weird thing. Now, we cannot put A on both things, right? Because if you put them, then you have 2x times 2x, which is 4x squared. But they gave us only 2x squared, right? So we did another wrong thing. But what do you observe in one of the factor? One of the factor is divisible by what? 2. So divide that factor by 2. What do you get? X minus 3, and keep your other factor. What do you observe? This and this, they're exact same two things. Right? One of them we got using normal AC method, and this is weird AC method. It's easier, right? It's weird, but easier. It doesn't make sense. Like, we did all these wrong things, but we got into the correct results. So this is doable as long as you don't do anything abstract, like too bad, too weird things. Here we did weird things, but not too weird. So whatever is easier for you, okay? You can use that method. I used to love AC method, the normal one, but once I learned about the weird one, I was like, cool, that is weird. I mean, that is weird, but it takes less time. For me, as long as you do it correctly, it doesn't matter. But the weird one is weird, so not every instructor will accept that. It's weird. But anyway, so it's not that bad. It just kind of weird. That's it. So that's why you like factoring, because factoring is easier, especially direct factoring is easier. And for AC method, you have to work on it. Now, not everything is factorable. For example, this one, x squared minus 8x plus 9 equals 0. Can you think of two numbers, when you multiply them, it becomes 9, and when you combine them, it becomes -8? It looks like it's 9 and 1, right? -9, +1, right? But when you multiply, what do you get? -9. But what is given to you? +9. So it's not factorable. It's not possible. There's no way you can find two numbers multiplied to -9, but combined to +8. Oh, sorry, multiplied to +8, but combined to -1. Not possible. So you cannot use factoring method. Then you have two choices. Either use quadratic formula, or you can use complete the square. Now, complete the square is much efficient than quadratic formula. Quadratic formula has two downsides. One is you have to memorize it correctly. And second, x equals -b plus minus square root of b square minus 4 is equal to a. This thing inside, if you have a, b, c big numbers, they turn into big number. And then you have no idea what is square root of a big number. So you get stuck. Okay? On the other hand, if you complete the square, you don't get this problem. You don't have to work with big numbers. That's why computer square has one good side, where quadratic formula has two bad sides. So how do you do how do you do computer square? Before you do that, let me ask you some questions. We are going to factor perfect square trinomial. What does that mean? Trinomial, how many terms we have in a trinomial? Can you guess? 3. That's why it's called trinomial. So we are going to factor trinomials. And it's called perfect square trinomial because when you factor, you're going to get the same factor twice. So the square factor. Now, let's start to it the beginning. We have x squared plus 8x plus 16. And if you factor two numbers, let me get it here. So, we have x squared plus 8x plus 16. Let's factor it directly because it's directly factorable. Two numbers multiply to 16 combined to 8. What two numbers we have? Plus 4, plus 4. So in other words, we have x squared plus 8x minus 16. Sorry, plus 16 is x minus 4 squared. Plus 4, sorry. X plus 4 squared. Right? When you factor, you get the same thing twice, so we square power. Now, if we subtract the 16 from both sides, we get x squared plus 8x is, because our 16 cancel out, is x plus 4 squared minus 16. Right? Now, let's keep it here. We don't have to do anything here. We are done. Let's take another example and then compare what do you get. Next example is, let me change the color. X squared minus 6x plus 9. If we try to factor, what two numbers multiply to 9 combined to negative 6? Can you think of two numbers? Negative 3 and negative 3. So x squared plus 6x minus 9 is x minus 3 squared. Sorry, plus 9. So you subtract 9 from both sides, and what do you observe? X squared minus 6x is x minus 3 squared minus 9. Now let's observe this result with this result. Do you see any pattern there? Do you observe anything in these two results?
Say the X is on the left side.
Okay.
But it's on.
What else to notice about the numbers?
The right side, just like it's plus 4, the 4, it's also like 4 times. No, the
Square root of 16.
yeah. And the same with the 9 has 3.
So one observation. This 4 is square root of 16. This 3 is square root of 9. Good observation. Fatimata.
Yeah,
Same thing?
4 is
Square root of that. Okay. Now if you compare left to the right, what do you observe in both scenarios? Look at the left and look at the right. Do you see anything, any pattern, any connection, any relation? We can factor, but we don't want to factor. If you look at these and observe that, do you see any connection between these two? 4 times 4 is 16, so whatever we have, that square is outside. Whatever we have, that square is outside. That's one part.
You on that side?
The left with the right.
Okay, so if you want to simplify x plus 4 squared, that will give you x squared. No, that's wrong.
No, it will not.
I'm thinking about that.
There's actually very easy and visible connection. They have to do with division. Do you observe anything? Not really. Divide what? Look at the left and look at the right. They are connected with the division.
It can be divided by the same number, like in this case, like it would be divided by 8, and the 16, it would be divided by 8 too. And the 6 and 9 down, it would be divided by 3.
But not evenly.
Not, yeah. And then I would do. First, I'm thinking it's half.
Good job. That's the connection. Whatever amount you have, it has to be half of that amount. And the half square is that amount. Do you observe that? Whatever we have here, the inside is half of that amount. And the outside is half of that amount square, right? That's the quadratic, that's the complete square method. All you have to do is observing x squared and x, put them together. As long as you don't have any number, then you can rewrite your left side into a perfect square. How? You write x instead of x squared, and you take half of your middle term. Always, whatever you have, odd number, even number, anything, whatever you have in front of you, x, the b, the inside will be half of the b. So half of the b goes inside the square. Inside the square. And you always have to subtract whatever you have here, that square. See here, your plus sign here, but you're still subtracting. We have minus here, so we have minus here, but you're still subtracting. So the subtraction is always, you always have to subtract the square, but inside the square, inside the parentheses, you're going to put half of your b. So how do you complete the square? You take x plus minus whatever you have for your b, half of b squared, and then subtract half of b squared. And that's how you complete the square. It's called complete the square, means complete your square. And why do you like square? Because at the beginning of the class, remember I showed you when it's squared, we can take the square root on both sides, or like we can see it. Now for you, let's complete these 4 things. The first one is x squared plus 2x. We are going to complete the square. So what goes inside your parentheses? Half of b. So in our case, what is our b? 2. So what is half of 2? 1. So we do half of 1, and we are adding because this is 1. So this is plus. So we divide our b by 2. That goes inside. And then what do we put the outside? Minus what? The 1 square. 1 square, which is 1. So half of b goes inside the parentheses, but that square is subtract after the parentheses. Now for the next one, we have x squared minus 16x. So inside the parentheses, what do you write? X and minus 8, good. And outside, what do you write? 64. So half goes inside, the square goes outside. The next one, 50. So what do you write? Plus 25. And then outside we write 25 square. 25 times 25? 625. And the last one. It's not even, but it doesn't matter. The rules are same. What goes inside? Negative 11 over 2, right? We're dividing 11 by 2. It's a decimal, so we don't have to worry about the decimal. We keep our fraction. It's half of negative 11. And what goes outside? That's square. So what is 11 square?
211.
Whatever we have here, that square will be there.
Here.
So what is 11 square? 121. And we are dividing by 2. What is 2 square? 4. So we have no idea what is that, but we don't care because we are looking at the square as a fraction, not as a number, as a decimal, just as a fraction. Okay? So that's all we have to do to complete the square. We only observe x square and x terms. So we only observe a and b, and then we can complete the square. So what happens to the c? We keep the c on the side, and then whatever c we have, that's going to be added with all these squares. Okay. Now let's do an example. Any question before you go further? Any question? Now let's try this one. We know this is not factorable. So we're not going to do factoring. We are going to observe only these two and complete our square. So our goal is to get x inside something square and minus something. And then you're going to keep on 9. So how do you rewrite x squared minus 8x? So minus 4 inside, and what goes outside? 16. And it's minus 4. What's minus 4? Half of it. So half of b goes inside your square, inside the parentheses. And whatever you have, that square goes outside the parentheses. And you always drop, always. So now, see these two are like terms, right? Minus 16 plus 9. So you keep x minus 4 square. And when you combine minus 16 plus 9, what do you get? Minus 7.
You don't have to add the 16 on the other side.
So now this is algebra. You add 7, so you get x minus 4 square equals 7. And then square root on both sides. So radical and square cancel out. We get x minus 4 equals. What do you get on the other side?
4 to each side.
Yeah, but before that, right now, when you take the square root on both sides, what do you get on the right side? Do you know what is square root of 7? We don't. So we definitely have square root of 7. But is it the only thing we have on the right side? Remember your plus minus symbol. Anytime we take the square root of a variable, our left side is a variable into the square root. So right side has to have plus minus.
They're always minus 16.
Always minus 16. There are other ways of doing it, but this is the easier one I found.
Yeah, I'm going to complete the script, but it's like a little bit different.
So then you have, now last you add 4 to both sides. So you have x equals 4 plus minus square root of 7. What does that mean? it means one of the axes 4 plus square root of 7 and another axis, I don't have space, so let me write a little bit lower. Another axis 4 minus square root of 7. Okay. And whatever square root of 7 is, we have no idea. We keep it.
The number. Absolutely, sorry.
If it is a perfect square number, like instead of 7, if you had 9, then it becomes plus minus 3. But you always have to do plus minus. And you missed y at the beginning of the class. So you can watch that recording. Okay, then I have 2 questions. So you try 2 of them. And then you're going to do 1 square root, 1 quadratic, and then you're going to leave. Can I flip my page to the left page? Okay. So try these 2. But before you go for complete the square, what do you observe? You can factor out or you can divide by 2. And then you complete the square. Let me give you one more. It's seen it before. Next up. X squared minus 3x plus 10 equals 0. Okay. Try these 3.
I have to do something. Oh, no, but I have to be off too. We have things like mine too, I get into interest of the truth, they told me to like this. And then it wasn't true, but it would be like. This thing, it's like I just said, here's one of the settings, yeah, like that, negative things or whatever. And I kind of did it last night, probably just a little bit. And I don't
Ready? Who would like to try the last one? Ethan, not so Ethan, come on, let me take it back on this. George. Ashley, Jaleesa, Michael, Lady, what's that? Lola, Jonathan, Reina, Denisa, Devanta, Nicole, Andy, Priya, Katie, Andrew, George here, Mariana here, Daniel here, Renata here, Asma Innocent, Shuing, Chloe, Ethan, Kathleen, Brandon here, Ryan here, Chahana here, Leonardo, Brian R, Brian V, Gian, Alex, Anastasia. Okay, George, go ahead. They added 22? Okay. You didn't have to do that, but you did it, no problem. X squared minus 4x plus 22 equals 0. X minus 2 squared minus 4, and we have plus 22. So we have this and this extra. So this is 18. So x minus 2 squared equals negative 18. So x minus 2 equals plus minus. But you have to split, right? So it's negative 1, and then what? 9 and 2. 18 is 9 and 2, right? You have to split it. Plus minus 3 equal to I. And then we add the 2. So x equals 2 plus minus 3 equal to I, which is x equals 2 plus 3 equal to I, and x equals 2 minus 3 equal to I. They're imaginary, so they're not real. But good thing we didn't have to plot them.
X equal, my solution of x equal 2 plus or minus square root of 18.
You cannot leave the 18. because it's reducible. Anytime you have a number reducible, you must reduce. So if you leave 18i, it's not wrong, but it's not acceptable. It is reducible, to reduce. Hmm?
What if I did that? T plus or minus 2 by that?
You mean here, this one? This is acceptable. Mhm. I broke it down to let you know, I mean, to show you that plus minus means there are two answers. But yeah, Ali, you cannot leave 18. Mhm. What is square root of 9? 3. And 2, we have no idea, so keep our radical 2. But square root of -1 is I. So I, 3, square root of 2. Who would like to try the next one? B, the next one. You already did one. Anyone else? We have no idea what's going on. If you try, then it will be easier for you. I'll help you. So let me pick one. Jonathan. Let's say you have no idea what's going on. So let me help you. What is your first step? What do you think the first step should be? You can start from here. Convert this into perfect square. It means you're going to write x square outside and minus something. Rewrite this in this form. So what goes inside? Half of 3. And what sign you have? Plus or minus? Minus. So minus half of 3. And what goes outside? No. 9/4. It's square. So not 5, it's square. 3 square is 9, 2 square is 4. Perfect. And we did not bring our 5 down, so minus 5 and 0. So now you have these two. They are like terms. So your goal is to combine them. So let me write the left. X minus 3/2 squared. Because I made a mistake. Thank you. So let me write plus 5 minus 9/4. So it will be plus and minus. It will be easier to combine. So you cannot combine any fraction with a non-fraction unless you have the same denominator. So you need a 4 there, but math is fair. If you put 4 on the denominator, where else you have to put 4? On the numerator. So now you have 4 on the bottom. And what do you have on the top? 20 minus 9, which is 11. So x minus 3/2 squared plus 11/4. And now it's simple algebra. We subtract 11/4 from both sides. And I need more space. So we have x minus 3/2 squared equals 11/4 square root . On the left, x minus 3/2. And how about the right? We have 11/4 I. What else? What is missing? Plus minus. You cannot forget your plus minus. This negative gives you I, and you separate the numerator with the denominator. Square root of 11 divided by square root of 4. Why did I separate them? We don't have to, because what do you want the denominator? That's 2. So it's simple. We add the 3/2 to both sides. So x is 3/2 plus minus square root of 11 I/2. That's it. You can combine the numerator, but we don't have to, because we are leaving the answer the complex number. We have no idea what that number is, okay? We don't care. The thing is, that's the format. It's something weird. Any question? Was any step unclear? Confusing? Now let me show you one more. Let's say we have 2 here, okay? So what if we have a coefficient? Mm-hmm. 2x squared minus 2x plus 10. Okay. 2x squared minus 3x plus 10 equals 0. What if we have a coefficient? Well, no problem. We already know what to do. Even though it's not divisible by 2, but we have to divide everything by 2. Because to complete the square, we cannot have any coefficient. Previously, we did divide by 2, and that time we are lucky. We had all the coefficients were divisible by 2. But this time, the middle coefficient is not divisible by 2, but it shouldn't bother us. We do x squared minus 3/2 x plus 5 equals 0. Now, who is brave enough to give me the inside and outside? Same rule, okay? Same rule, same everything. Good job. It's half of, so half of 3/2, right? What is half of 3/2? When you multiply, you get 2 times 2, 4. So we have 3/4 inside. Nine over 16. Because you're squaring. You see? And then you do the rest, like the way we did in the left page. The main idea here is, it doesn't matter what is your coefficient. You can always use complete the square. When your b is not an even number, we get something that is not even, we get a fraction to work with. But the rules are same. You take half of your b, and then you square the outside, square on the outside. Okay. Any question? Because complete the square has a requirement. For example, in order to be a Baruch student, first you have to pass the high school, right? At least have a degree, high school degree, right? So you have to be in Baruch, you have a requirement. You have to have a degree, high school degree or something. Same thing, in order to apply the square method, perfect square method, you have one requirement. Your A has to be 1. But in the original one, what is our A? 2. So we cannot apply, we cannot go for square method until we convert these 2 into 1. Okay. So if in order to get the, you have to fulfill the requirement, we need to get rid of the coefficients. No coefficients. A has to be 1. X squared cannot have a coefficient. Let's leave it here. In our next class, we are going to do quadratic formula. But quadratic formula has two downsides, remember. Remember the formula correctly and the square root of a big number. We'll see you all on Friday. And remember, next week, Tuesday, no school. Sorry, Monday schedule. Thank you. Thank you.
So good. Have a good day.